Alright, welcome back. So in this video, we're going to now be focusing on actually creating the VPC or writing the code that will help create the VPC for us. As mentioned earlier, we'll be using a module, which essentially means that someone else at some point put together this, set of resources that help us, help it make it easier for us to then create a VPC. Right, so because we're using a module, rather than use the resource block, we'll be using the module block, right? And similar to the resource block, we will then have to give it a name. So I'll just say module VPC. Now, modules have to have a source, right? So they could be coming from your local machine, or they could be coming from a Git repository, but they also can be coming straight from the Terraform registry, as in the case of this one. So because we're going to be getting this from Terraform, we just need to say Terraform dash AWS dash modules slash VPC slash AWS, right? And what will happen is when we run the Terraform and download this module and keep it in our local environment, right? So the next thing we have to choose is a version, and I'm gonna work with 5.0.0. Okay, now we're kind of done with what's required to download the module. But in order to provision the VPC, we then need to start passing it some of the attributes, or arguments rather, that are required. Right, so the first thing we're going to do is we're going to give it a name, and I'm just going to say, in this case, because remember we created those variables earlier, right? So that's what we're going to use here. So we're going to come back to main, and I'll say var.vpc underscore name, right? Then in terms of the CIDR, I'm going to do the same, right? I'm going to say VPC CIDR, right? So these variables are really kind of making life easier at this point. Now, it's going to need availability zones, right? And so how I usually approach this is that this needs a list of them. So how I usually approach this is by passing the region, right? So what I usually do is I'll pass the region. I believe I have a region variable. Then I say a, that'll give us AZ's whatever the region is in the A section. So right, what that will, so because we in the EU West 1 region, our subnet would be named so like that. So it just makes life easy for me instead of typing everything, right? So I'll do the same here, where I'll say var.region and I'll pass B, and then same thing here, var.region C, right? So just like that, yeah, we'll get the availability zones that we need for as part of our VPC, right? Then the next set of things is the subnets, right? Subnets, and remember we're building a 3-tier VPC, meaning that we're going to have some resources sitting in a public subnet, some in a private subnet, and we'll possibly even have databases which also sit in a private subnet. And how this module works is that it allows us to do that quite easily. So in terms of the public subnets, so I'm going to say public subnets. My typing today is horrible. Okay, public subnets, and so subnets are actually kind of interesting, right? Because similar to how our VPC gets a CIDR, they too will need a CIDR value. And so there's kind of like an easier, well, not necessarily easier, but a way that kind of makes it simple to assign CIDR blocks, right? So rather than typing 10.01 slash 24 and then repeating this 9 times, because we have, sorry, let's fix that. Because we have 9 subnets, we can have these automatically calculated for us, right? And how we do that is that we essentially loop through the number of availability zones that we have, and in doing so, we then create a subnet in each, and in creating a subnet in each, we also automatically at the same time create calculate the CIDR value for each of those subnets, right? So essentially that's the whole strategy here. So how we do that is that we'll loop through our local AZs here. We'll loop through them, and every time we loop through them, I'm going to use something called the CIDR subnet method, and this is native to Terraform. It takes 3 things, right? It takes 3 values, one of which is we're going to need to pass it the VPC CIDR, and it's going to use that CIDR to then make calculations, right? So the next thing we have to pass it in a value, and we'll pass it the index of where we are, right? And just like that, it'll help calculate these CIDRs for us for these CIDR blocks. All right. So I'm gonna do the same for the private subnets here. All right. So I'll do 4. I could have just copied, but I like typing. Dot azs. Okay. CIDR subnet. Okay. Let me just fix. Let me just fix this. Okay, cool. Again, we pass it the. I don't know why it keeps doing that. Just so weird. Okay, cool. Again, we're going to pass it a second value, but remember, these have to be unique, and so when we pass it the key, we will then add another random value here. Then we're going to do the same thing with this database subnets. Okay, we'll also loop through the locals dot az. I'm just not going to use autocompletion, to be honest. CIDR subnet. Okay, and in there we'll say VPC underscore CIDR, pass it a value, then pass it the index like so, and that should be enough. So we've taken care of our subnets, and also we didn't have to manually type in the CIDRs, which I think is pretty powerful, right? So now we're going to pass in a couple of options as well, because we have what I'm going to do here is we're going to now handle the database related configuration. So one of them is create database underscore subnet group, which I think let's do that. Remember, subnet group in AWS, a database needs more than one subnet, right? So, and that is called a subnet group, and that's what we do here. So we're going to have more than that. We're going to have that created for us, and it'll be attached to, so should we then create a database, we can just pull that into that database when we configure it. The next thing is create a database route table. I'm going to say true to that as well. It'll be isolated from the route tables of the public and private subnets, and then enable a net gateway. I'm going to say true here as well, especially if we can, because as best practice, what we want to do is we in our 3-tier application, we want to have our servers seated in the private subnets, all of our business logic. But sometimes our business logic, even and when it's in a private subnet, remember, it doesn't have a public IP, meaning the outside world can't talk to our services directly, right? Which is a very good thing, gives us security. But the opposite is also true. It means that our services cannot directly speak to the internet, right? And so how a net gateway comes in handy is that we place our net gateway in the public subnets, which makes it have a public IP. And whenever our services in the private subnets need to make any sort of connection with the public internet, they'll go through the net gateway. And the net gateway will take the private IP, translate it, and be able to make those calls to those services, to the public internet, then come back and give responses to our services in the private subnet. So that's pretty good. Single net gateway, it'll be true. We just want one. We don't want a lot. And then let me just separate these. I'm gonna say these are net gateway configs. Then the next thing we're gonna do is VPC related configs. So we want our default VPC DNS names to true, and we also want VPC DNS support. We also want that to true. And then for any of our public for instances launched into the subnet, particularly in the public subnet, want them to be automatically assigned a public IP, right? So that's it, really. So now we're going to work on the tagging. On the tags, I'm going to say public subnet tags. And one of the things I like to do here is, I'm just going to say name here. I like to pass in the VPC name here, and then say public subnets. Just makes it easy to read on the console. Yeah, that's it. That's what we're gonna do for the public ones. And then we're gonna say I'm gonna do something similar. I'm gonna say name. Then we'll say var VPC name, and then we'll say private subnets. Same with the database ones. Say database underscore subnet tags. Okay, say name. Let's say VPC var dot VPC name database subnets. Okay. Then we want to lastly finish off with the VPC tags, right? Where I'm just going to say name and really just pass it the name of our VPC. Again, just for easy readability on the console. I don't think, do we have any other tags here that we added? Let me just check here. Yeah, then I'll add these other tags here as well, because this does permit us to add other tags, and I'm just going to say var.tags. Okay, cool, that's it. That's our VPC, right? So all we now have to do is, I'll just switch over to git bash here. Much more prefer git bash. And then I'll export the profile, cloud space. Once we've done that, we can then run Terraform in it. Okay, so now if you look here, downloading registry Terraform IO, and it's downloading that VPC module as we stated here. So it's getting it from that source over there, right? And it's getting the version we also stipulated here. If it didn't stipulate a version, it would just get the latest version from the registry. But I don't like doing that, because you want to lock down your modules to a particular version, so that even if new versions are introduced, they don't introduce breaking changes into your infrastructure, Right, so it's downloaded, which is pretty good. Now all we have to do is run Terraform plan. Right, and obviously the plan is going to tell us what is going to be provisioned, right? So it's already created the state file, and so we'll see that get populated. I don't think it's going to show. Maybe in a future video what I'll do is I'll talk about how we can have our state file really stored remotely on S3 as well as on Terraform Cloud. Okay, cool. It's time for debugging. Is not expected. Yeah, I probably made a mistake here. Alright, so let me just go and fix that. Cool. Let's try again. Hopefully, I think that was the only error that I had. So I mean, expect errors. It's normal. I'm just checking for more here. Right, there's a lot. I think I probably misspelled this function as well. Let me go up. Let me just go up here. See what other errors we have here. Okay, it's really the only one. Okay, it's planning to create all of these other resources except for the error that we have. Okay, cool. Let me just fix that quickly and then we can move on. And what I'm going to do is, because there's three of them, I'm just going to do Control T and fix all of them at the same time. Okay, there we go. Yeah, this now seems to be highlighting on it, so it should be fine. So run Terraform plan again, and I think we should be okay, unless we run into another error again. There we go. It's gonna add 31 resources. So I think what I'm gonna do is, I think this video is getting long. I'm going to stop here and then I'll come back and then I'll do the apply. Then we can see all the stuff that gets provisioned. Right, so thank you so much for watching and I'll see you in the next video.